Hello students, so our topic is finite automata. So far we have seen all basics. So necessary basics we have covered, correct? In terms of models, in terms of languages, in terms of grammars that we have observed very clearly. So now we will see finite automata. This is the first mathematical model. This finite automata can be like two things. One is finite automata will do language recognizing, and second aspect will do output generator. The finite automata is what? Language recognizer or acceptor, we can say, or we can say acceptor. And second one is output generator. So what is the meaning of language recognizer? So FA with output, without output, this we are calling, see all of you. So FA without output is language recognizer. There are two things will be there in language acceptors. One is FA, that is FA nothing but so we'll call DFA. Second one NFA. So already we have seen what is the difference between DFA and NFA. Not exactly, just I told you FA comes in two flavors, that is deterministic finite automata, non-deterministic finite automata. We have observed, correct or not? This will come into two flavors. Now what I'm trying to say, language recognizer acceptors are DFAs and NFAs, which are FA without output, and FA finite automata with output, or two things will come here. This is language generators, output generators. It is not language generator, output generators. One is More machine, and second one is Millet machine. So as I told you, FA is implemented in hardware switching theory. I told you, correct or not? In circuit design, I told you. So we are using finite state machines. We are using. This finite state machine, nothing but one is More machine, another one is Millet machine, which are practically implementable in switching theory, which are little output generators. And FA and DFA, like DFA and NFA, only language recognizers are acceptors. So now two aspects we need to understand. The first, I will focus this recognizer. The first aspect will be focusing now. Then later I will take million more machines now. Now, as of now what I'm trying to say, I have to take FA without output only. That could be DFA or NFA. The first I will talk about DFA only. So DFA we can call FA also, right? As I told you very clearly, FA by default DFA. PDA by default NPDA, yes or no? Turing machine by default deterministic Turing machine, as I told you, right? So now I am talking about FA, that is nothing but DFA. I will take it. So look all of you. So finite automata or deterministic finite automata we will call deterministic finite automata, DFA, by default DFA only. The formal definitions I wanted to give, note down. Mathematical representation of regular language is called FA, or FA is a device that processes the states. It is a mathematical model that is processing what? States. So processing states, nothing more, you understand, it is just like reading the string, like taking input and moving to next state. That way you understand. So it is simply mathematical representation of the regular language. As I mentioned clearly, so FA will accept a regular language, yes or no? FA like regular grammar, regular language, some basic introduction I given, right? So it is processing what? A regular language only, that you understand. So other definition, if we see, FA consists of finite set of states. FA consists of finite set of states and set of transitions from states that occur on input symbol chosen from the alphabet sigma. So in this definition, so many terms are there. What is alphabet? What is symbol? Yes or no? What is language? These are the basics we have observed already, right? FA consists of finite set of states and set of transition will be there. Transitions like this, Q0 on A, Q1, like this is a transition from here to here, transition from state to state that occur on input symbol. This is the input symbol. chosen from alphabet. If I take alphabet, if I take a comma b, like this, we will understand with the example that I am giving the definition now. Next, so for each input symbol, there is exactly one transition out of each state, possibly back to the state itself. So what I'm trying to say, in a FA, for each input symbol, exactly one transition should be there. Are you getting my point? So how many alphabets if you take? For example, if you take a sigma alphabet A comma B, if you take for A comma B symbols, right? These are two symbols for which in each state there must be exactly one transition should be there. That is the point we have to understand. Anyway, we will understand with the examples. Okay, just you have to note down these points very clearly, all of you. One state usually denoted as a Q naught is an initial state which the automata starts. Q naught is what? Initial state where finite automata begins. That you understand. Suppose if I take sigma A comma B. So if you take Q naught, okay, Q naught on A, Q1 assume that, and Q naught on B, Q naught only, Q naught A comma B, it is going to be Q2. Q2 is the accepting state, assume that. This is repeating A comma B. If I take small fa, you understand alphabet I have taken A comma B. For A comma B, I have mentioned transition at each and every state of FA. See, Q naught on A, it is going to Q1. Q naught on B, Q naught itself. Q1 on A comma B, it is going to be Q2. And at Q2, A comma B is looping self loop. This is called initial state. This is initial state. This is the final state we will call. And what is this transition? This is a transition. Transition meaning what? It is moving from one state to another state on taking input symbol. Are you getting my point? So taking input symbol A, it is moving 1 to Q0 to Q1. Right, see, understand, see, finite set of state and set of transitions from state that occur input symbol chosen for alphabet A comma B. Also I mentioned FA is what? Device that process the state. States are processing, right? Like it is moving one state to another state. That way you have to understand, all of you. Another point is, see, some states are designated as a final state or accepting state. So previously I mentioned clearly, yes or no? So I have shown two circles, that is nothing but final. So that is nothing but final state or accepting state. It could be one or more final state possible, but only one initial state is there, that I will observe later. Other definitions too you can be observed. All of you are you getting? Either you can say mathematical representation of regular language nothing but FA, or you can say it has set of states and transition. Then definitely there must be exactly one transition for each and every symbol at each and every state. And in FA, that is BFA, one initial state, many final states will be possible. Other definition, if you see, FA, a finite automata is a phi tuple. Please do understand. So finite automata is a phi tuple. So what is the phi tuple? We will observe. If you see the phi tuples, so let me write here. All of you observe. As I told you, if I take M is the FA, it is phi tuple. Phi tuple. What are the phi tuples are there? What are the phi tuples are there? So look this, all of you. One is Q and sigma delta, small delta, Q naught F. How many is there? 1, 2, 3, 4, 5. So phi tuple, phi, these are the tuples will call. What is the Q representation? We'll understand. So all of you write a number of states. So number of states in FA, this definitely finite only. Q should be always finite number of states will be the set of all states or number of states, you understand, that always finite only. What is sigma? This is input alphabet. So alphabet definition we know, right, all of you? This is sequence of symbols only, right? Alphabet. Correct or not? So now transition. This is delta. What is delta? Transition. Transition. What is delta ma? All of you have to note down this is. So delta is transition function. So transition function. I will define later some more. And Q naught. What is Q naught? Initial state or start state, you understand. Initial or start state. What is F? What is F? Final state. So final state. Please do understand, all of you. this F is subset to Q. What is Q? What is Q? Q is what? Number of states. F is subset to Q, nothing but F final state could be one, two, more. All state can be final also. That you have to understand. Are you getting my point? Q naught. What is Q naught? You understand? Q naught belongs to what? Q only. One of the state only Q naught. So now transition function, if you observe all of you, some function will be there. See, it is taking all of you, please to understand. So from each state Q is the number of state, right? Each state Q, you have to take input symbol and you have to move to state only. So this is a transition function delta. This must be you note down and understand. Many times we will observe. Are you getting my point? So for which I will take example also how this function will come. Suppose example Q naught on A, Q1 assume that. Q1 on B, Q2 assume that. Suppose this is final state in number of A comma B. This is A, this is B assume that. Initial state. See, transition meaning of moving from one state to another state. Or state one state to another, it can be self loop also there. Same state also can come. Are you getting my point? See, in each state, alphabet is common. Like alphabet, all symbols I'm using or not. And see, so Q naught is a state. I'm taking what input symbol A. It is moving to where Q1 or not. I'm moving to Q1 only. What is Q1? State only. Yes or no? Similarly, suppose Q1 on B, Q1 on B, Q1 on B. Where I'm going? I'm going to be Q2. Q2 again state only, correct or not? I am defining. So I am taking from state only with the state and taking input symbol, okay, input symbol, then moving to state only. This is what transition function. At each state, I am taking input symbol, that is alphabet. Alphabet A comma B will be there, both will be there, see, and moving to state only. So this is called transition function. So you can define FA is a 5 tuple, this 5 tuple representation, like I mentioned. So please note down, all of you note down, please. Some point I will tell you. Look, all of you, some point I want to tell. Suppose example, if I take, so sigma equal to 0 comma 1 is there. So I will take one FA Q naught, okay, initial state Q naught on 1, Q naught only, Q naught on 0, Q1 assume that. So this is repeating. So this is on 0, this is on 1, assume that. So now you see here, what is Q naught? Q naught is nothing but what? Initial state. Are you getting? What is Q1 here? Final state. Why? Final state represented as two circles. Initial state represented like this. Initial state represented like this. Final state represented as what? Two circles. That you have to understand. Initial or start state, you can say. So one more example also I can show. So I can show one more example. See, now look this. Another FA I am taken. So please note down this. Here, what is A? What is A? A is what? Initial state. How to observe? See, this is symbol is there, right? So circle, and this is representation what? Initial state. Now what is final state? C is what? Final state. Why? Because two circles are there. Are you getting my point? That you have to note down. Note down, all of you. Representation of FA. Now definitely we will observe how strings are processed here. Means input symbols are string, how it is processed by the FA, that will observe very clearly. So just simply you follow only, just the flow you try to follow it. So each and everything we will observe very clearly now. Please do copy, all of you. Some notes we will observe, some note point we will observe here. By default FA is nothing but DFA only, as I mentioned. Yes or no? I mentioned or not? By default FA is nothing but DFA only. Another point, DFA is a mathematical system with finite number of states, IO mechanism, input output mechanism. I should not tell. Yes, it is input output mechanism, both will be there, right? Mathematical system, it is finite number of states will be there. Yes. Third point, FA has only one initial state. Yes or no? See, only one initial state will be there. Only one initial state will be there. FA can be constructed with without final state. Yes, this is possible. You would understand. FA can be constructed with final state, without final state also. Suppose if I take Q0 on A, Q1, that's all. On B like this. So this is A, this is B. So this is simply what initial state, no final state is there. Initial state and number of states are there, no final state here. Possible, but what we'll accept later we will understand. Another point, number of final state in FA is 0 or more, yes or no? I can have this could be also final state here. This could be also final state. We can have 0 or more final states, that you have to understand. So DFA is a complete system that will respond for every input string. So we have to define a transition for each and every input symbol and each and every state. This is very important point, ma'am. To understand DFA, now we will get DFA definition only directly. Nature of DFA we will understand from this point. What I am trying to say, DFA is a complete system. What is the meaning of completeness? What is the meaning of complete? Complete means understand the system will respond for each and every input. Input could be right or wrong, it will respond. Suppose the example I will take. You might have experience with ATM machine, correct? You might use that also, correct? So that I am trying to say that is a complete system, like you can understand DFA. Example. So what is the meaning of completeness? See, when you try to use a ATM, I mean suppose you want to do some transaction withdrawal of some amount. What do you do first? You will insert the your ATM card. First we have to do language selection, then PIN number entry. When you are entering PIN, if you enter the wrong PIN, then what happens? System will respond or not. When you enter the PIN is incorrect, it will respond or not. Yes, it will show it is invalid or incorrect PIN. Yes or no? So now when you give valid PIN, what happens? It will go to next step. What is the next step? After PIN entry, you have to select withdrawal or a transfer. Some functionality will be. See, based on your input, it is moving state wise or not. See, will go like initially language selection, PIN number entry, then PIN is correct next level, then withdrawal, then like complete transition. Like step by step going on. In each step, we are giving input or not. The input could be right or wrong. It will respond. If you give right, that it will go to next step. If you give wrong, that will respond. The completeness nothing but system will be responding for each and everything. And DFA for which you understand whatever alphabet you take for alphabet A comma B if taken. Okay, suppose states are there, Q0, Q1, Q2 states are there. You understand each and every state, at each and every state you must give a transition for A comma B comma C exactly one time only. Exactly one transition for each and every symbol at each and every state. Then only that system is called complete system. Also let's said to be what? DFA. I hope you are getting, because this definition will change for NFA. So DFA telling what? Each and every state we must give a transition for each and every input symbol which you specified exactly one time. After taking input symbol from sigma, the DFA moves to exactly one state only. Exactly one state. Are you getting? So if Q0 is there, Q1 or say Q0 on some input symbol it will go Q1 or you may be going to self loop. But exactly one move will be happen. Number of transition in DFA state equivalent to what? Number of symbols. So number of transition at state. Suppose I have taken A comma B C. So now I have to give Q0 on A, suppose Q1, Q0 on B, Q2, Q0 on C, Q3. See, number of transition at a state. See, number of transition DFA state. In DFA state will be how many? Length of the symbols. How many symbols are there? 3. So now 3 transitions will be there at each state, that you have to understand. These are the very important points we observe for FM. Thank you.